that's dark. I don't like that. I gotta change my camera settings real quick. Hello, everyone. Let me change my camera real quick. I tried streamer mode on my camera. Apparently it does not look good.
Good is subjective, I guess. I mean, it depends on what the mood you're going for is.
I was going for dark and mysterious, apparently. Good to see some regulars. L30.
Yeah.
How are you, sir? Kumo. Hello.
Welcome back, everybody.
Sozi. Another regular. Hello, Sozi. I have a dog here. I hope you can hear him slobbering on me. Ping, good to have you. And everyone else, of course, good to have you. I got slobbered on. I have food close by, that's why. Come on, go somewhere. Go somewhere else. We can give a couple minutes for peeps to join, and then whenever you're ready, say the word.
I'll go ahead and share my screen with everybody, just so we can get session started here.
We're missing some folks. I'm going to go annoy some people. Human information hazard. Good to see you too. You've been to quite a few of these recently. Oh shit! Ange is here. I don't have to edit that swear word out because my YouTube is not rated for children. Jacob, good to see you. Hello, sir.
I saw the word coffee in the chat.
Well, here we go. Study group's over with for AD. We're on coffee now.
Yeah. Sorry, we're going to talk about today's topic. Actually, it's just a fishing lure. We're going to be talking about coffee roasting 101.
Topic of the day for Ben: Starbucks.
Blairberries is right, Fox. You know it. And you can have your Charbucks. Drink it all day long if you want.
Folgers.
I kind of pegged you for like a Maxwell House kind of guy, but
My dad used to drink Maxwell House. I usually drink Black Rifle, but I will admit right now they didn't have any, so I have Starbucks espresso blend. Yes, I definitely drink Black Rifle.
we'll let it go this time, Sean.
I appreciate that. Well, if I have an IT job starting soon, I have to switch to better coffee. That was the rule. So
It is. It's prerequisite. If you're an IT professional, you have to drink. You have to grow your neck beard and drink expensive coffee.
Well, you won't be able to see my neck beard under this.
It's okay. You can just grow it out a little bit longer than the rest of it.
I actually don't have much of a neck, so it'd be hard to have a neck beard. I'm built like a Minecraft character.
This is your neck beard, right?
I remembered to hit record today too, so
I'm definitely always under that beard. Definitely.
I'm trying to get it back to. When did I shave it? Like July? I don't remember. Trying to get it back there.
I just keep going with it, man. Keep going with it.
Mm-hmm. It was immediate regret.
Yeah, definitely had that experience before. A little trimming error, and then you're just, well, screw it. It's gonna take
yes,
it all off.
Jacob. I just have like super alpha jaw under this beard.
Dirty and Folgers commercials.
Well, it's 7:06. I think everyone who's coming is coming.
Yeah. Cool.
I'll hop
all
off
right.
the stage.
I think you all should be able to see my screen share.
No.
Anybody confirm?
We do not.
No? What? God. Hang on. Try that again. Rookie mistake right there. How about now?
We got it. The best,
all right,
the best Kali Linux desktop. I can't speak tonight.
Yeah. Okay. Let's get this thing started. Before we kick off the lesson plan, just a quick recap about I think it was 2 weeks ago. Yeah, looking here, January 8th is when I have that. In my last was about almost 2 weeks ago. We talked about an Active Directory overview. I'd like to go over that really quickly. Again, I'm not going to make it as long as last time, but just I want to just reiterate from last week again, because since we are touching on internal methodology, if it wasn't clear before last time, just you need to think about Active Directory again. Think about it in terms of what problem is trying to solve. Because again, when you're pen testing products, whether it be web applications or mobile apps or desktop apps, even Active Directory itself as a product, they're all from an engineer's perspective. There's a problem they're trying to solve, and so you have to think about it from that point of view. What problem is Active Directory trying to solve? And that is primarily identity management. So if you think about Active Directory, and this link, I'll share this link again in the chat so we don't have to go through the entire thing here. You all can review it if you'd like. But the entire premise behind Active Directory, largely, other than being a bunch of protocols bundled together in a single product, like certificate management, identity, user and service account management. At the end of the day, you've got a directory that hosts user and group objects, and those user and group objects are sorted into units based on privilege level and things that the user or service account needs to accomplish. So if you think about Active Directory in that lens, that's going to help you during your Active Directory pen test. I think the most important thing I'm trying to drive home here with these lessons, the last week and this week, is that a lot of the blogs and videos and resources you'll go over are going to teach you about kind of like just rehearsals for situations like, if you're in an engagement and you see XYZ, do this, or use this tool for this situation. And there's nothing wrong with learning it from that perspective, but it doesn't really help solidify the bigger picture of what Active Directory is in general. And primarily when you're using these tools, I think you'll see one common pattern is that they're largely crafted around the idea of passing some sort of credential to further your level of accessing the engagement, whether it be a ticket or an NTLM hash or a cracked password. A lot of these tools are crafted around the idea of capturing or passing credentials because even though there are certificates and other services bundled into Active Directory as a whole, there are certain user accounts or service accounts that are assigned those privileges to manage those specific services. So the idea during a penetration test, the more you can dig around or use certain tools to gather credentials and store them and spray them around the network, that's the large, and at risk of oversimplifying it, really your Active Directory pen test is largely comprised around gathering credentials and seeing what you can get access to and your objective may not always be domain admin. It's going to be defined by the penetration test scope, but largely, Active Directory pen tests may have the goal of getting domain admin, and there are many roads to that. And again, most of the way to explore those roads to domain admin are encompassed around the idea of gathering credentials and spraying them. So keep that in mind during your whether it's the OSCP, PNPT, PJPT, or any other certification exam that's where Active Directory is the core focus. Just remember, when you're starting your engagement, you're trying to gather credentials that you can potentially spray around the network with the goal of furthering your access until mission accomplished. So again, the benefit to Active Directory is single sign-on. So you have one credential that could be used to sign into many places, maybe an SMB share, a web app, again, different services like LDAP or what have you. That single credential, the single sign-on benefit to Active Directory is also a curse in that if the credential is compromised, you potentially have access to a lot. But also, if Blue Team catches on and rotates the password, you also lose that credential. You don't. So it's a double-edged sword for sure. Quickly talking on Active Directory methodology here. Just pointing out the process by which we gather credentials and spray them until mission accomplished. So depending on where you are in where you start in the pen test, is if it's an external or an internal, this point here, exploit, is going to look different. So if you're on an external, your initial point of exploit may be on like a VPN or a webmail server, a web server, some other externally facing service where you hit this, you get a shell on here, potentially escalate privileges, and then you do your reconnaissance after your initial exploit and privilege escalation. You figure out what your next hop is. So exploit's different depending on the scenario, whether it's internal or external. And then you land on the box, escalate your privileges, try to gather your credentials from that box, gather what you can, and then enumerate more and figure out where your next pivot's going to be. And then once you've pivoted to the next machine, circle back, So this assumes that your credential or whatever you've happened to capture during your post-exploit reconnaissance, this assumes that you're going to get another shell on another box, and you repeat this process until the mission is accomplished. But again, by and large, this process typically involves finding a credential and passing it, or finding a vulnerable service on a box and exploiting it and landing a shell. And again, just repeating this process here. So today's lesson plan, also really want to show you really quickly as well, the diagram. I think the network diagram was here. So this was last week's network diagram. I added this to the lesson plan last week. Later after the exam, after the lesson plan, I should have shown you this before we started, but you can see here, this was Kali on the 10660 network, getting in through the 1099.199 host, and then this host has a NIC on both networks, so we can pivot out into this other network here. That's what we were doing last week on our external assessment. This week on our internal assessment, we're starting with Kali inside of the network, the 1080.80.0/24 network. And in this network, you'll notice we have a domain controller, and we have 3 Windows 10 hosts and a single Linux box joined to the domain, but they're all under the same network. They're on the same local area network. So this will allow for some different attack vectors. So what we're going to start with for an internal assessment is responder LLMNR poisoning, linked local multicast name resolution. So the way we're going to go about this is I've simulated user activity on the domain joined boxes by running some infinite loops. I've opened PowerShell or Bash, depending on which host. And I've essentially just used an SMB client to try to fetch a share. And this simulates user activity, like they log in and they're going to access their file share. Now, why does this work? When the host, so let's say, and we'll see this I'll show you this in the example in the practical here in just a moment. The reason this works is that some people might use old DNS names. So let's say there used to be a file server called file SVR01, but the system administrators renamed it to SMB01, and people are still using that file SVR01 name to try to map that share. That's no longer a valid DNS name. So when the host asks the domain controller, hey, domain controller, what's the IP address for file SVR01? The domain controller is going to respond, well, that name doesn't exist. We don't have an IP for it. What happens next is the host sends a broadcast on the 224.0.0.0 range. That's a multicast DNS broadcast to the entire local area network. And the element, I'll show you that in a Pcap in a little bit. I actually have a Pcap to explore that. But what happens is that initial DNS request to domain controller fails. We send an LLMNR broadcast out on the network to say, hey, does anybody else know the IP for file SVR01? And we just so happen to have Kali on the internal network running on the same local area network. Because it's on the same local area network, Kali catches that broadcast and says, yeah, I know where file when the user should have, remember, the user should have typed SMB01. They mistyped it, and responder says, well, yeah, I do know where file SVR01 is, and that's at my IP address. So they respond to that broadcast saying, yeah, sure, file SVR01 is right here. And that causes the client to initialize a net NTLM v2 authentication sequence to Kali's IP. That's why the poisoning works. And the prerequisite to that working is you have to have a host on the same local area network. If we were looking at an external, that would not work because Kali cannot poison the response through a pivot, but you could potentially install a tool on the pivot and then relay that back to Kali through your pivot. It'd be a little bit more complex. It's possible. It's a lot more work, but in this case, since Kali, we're on an internal assessment, we're already assuming breach and internal compromise. Kali's on the same network. We're catching that broadcast and we're poisoning it. So let's take a look at that in action. So we won't have to wait long because the way my user simulated user activity is working. Let's go ahead and kick off responder here. And we should be catching hashes here in just a moment. Assuming I didn't completely screw up the lab. There we go. Okay, so let's take a look at what we've got here. We've got 3 net NTLM v2 hashes here for John Doe, root, and we're going to ignore that because that's root on our Linux box. I just wanted to show you it's possible to capture root's hash using SMB client. This is root running on a Linux box, trying to map a non-existent SMB share. And you'll see here what responder's telling you here is this client 108083 requested John's PC .local, and LLMNR poisoned that response and said John's PC.local is at Kali's IP. And that caused John Doe to send a net NTLM v2 authentication sequence. And here, you'll know, sorry, I totally lost my train of thought. But regardless, you'll see here John Doe, password hash, root, password hash. Again, we're going to ignore those, and we'll go ahead and follow along with the lesson plan. Oh, that's what I wanted to say is the one thing you should be mindful of is when you're running responder, you can use the V parameter or flag so that even if you've previously captured this hash, it'll output it to the host here. If you had already captured this hash and you didn't run it with V, responder is going to just say something like hash has already been captured, so if you want to continue to display that even after capturing the hash, just run responder with the V flag. Okay, so we've captured some user hashes, and I'm going to save. Basically, I just made it easy for myself, but what we're going to do is essentially take these hashes and output them to a hash file. Sorry, let me change one setting in my remote desktop so I can continue. I want to capture that keyboard input. All right. So I can use Alt-Tab inside of Kali. There we go. Now, so we'll take these hashes and we'll go ahead and output them to our hash file. Referring back to our lesson plan, we're going to, before we attempt to crack those rather, we're going to take that brief detour to inspect that Pcap to show you why the LLMNR poisoning works. Just a very brief detour here. So, see, we'll go ahead and run sudo Wireshark and background that. And we'll open the Pcap. I think it's here on my desktop. right here. Make it nice and big. And then what I'm going to do is just do a display filter. So we'll do SMB traffic, LLMNR traffic, and DNS. So we can look at two pipes here. This display filter is where it's an OR filter. So show me SMB or LLMNR or DNS. And what we're going to see here is that at 10.80.80.3 in this first frame here is asking 10.80.80.2. This is the domain controller's IP. We're asking for we're sending a DNS query. Hey, what's John's PC.80.lab? In this frame here, 80.80.2 is responding that host name does not exist. And here's the LLMNR traffic right here. Let me try highlighting that again. Here's the LLMNR traffic sending to the IPv6 and IPv4 multicast addresses saying, does anybody on our local area network know what John's PC IP address is? And here's Callie responding, well, yes, it's at 10.80.80.5. And if we look at Callie's IP address here, let's see, let me kill my Hack the Box VPN. You'll see 10.80.80.5 is our IP address. So we're causing 10.80.80.3 to authenticate to us at 10.80.80.5. And you'll see right here, these are the IPv6 addresses, the IPv6 link local addresses. But you'll see here, this is the SMB negotiation, where 10.80.80.5 or this link local IPv6 is asking to start an SMB session with Callie. And that's why LLMNR poisoning works, is that spoofing or poisoning. Moving on, the key takeaway here is that multicast DNS broadcasts using LLMNR, because the broadcast goes out, goes out on the local area network, and because Callie is also on the local area network, responder receives broadcast and poisons it. All right, back to our regularly scheduled lesson here. We'll go ahead and attempt to crack these hashes using a custom word list that I've made. Let's go ahead and look at password list.txt, and you'll see it's just a combination of junky passwords here. Let's go ahead and put that in there. Sorry. And you'll see we've cracked all three hashes for root, for John Doe, and test user. So the reason it's better to have a clear text password as opposed to an NTLM hash is because certain things like remote desktop or probably WinRM, I'm not certain about that, but certain protocols will not let you authenticate with an NTLM hash unless you're a local administrator. Just off the top of my head, I know remote desktop is like that. I'm certain SMB should be fine. You can probably pass the hash with SMB and try and still authenticate or still get some level of access. But I know RDP, unless you're a local admin, you're not going to get on the box unless you have a clear text password. So if you can crack the password, it's better. But if you can't, there's nothing wrong with spraying that hash around the network and seeing what sticks. So we've cracked the hashes. And so now what we're going to do is take these passwords and hashes, take the username, the password, and we're going to add them to username.txt. So John Doe goes username text. John Doe's password goes to passwords.txt, etc., etc. So let's go ahead and do that. And then we'll take a look at usernames.txt and passwords.txt. And so you'll see your John Doe is right here, test user is right here. what we're going to do is spray those around the network and see what we can get. All right, so we'll take this crackmap exec command here. And just a couple of quick pointers. I'm also appending the node brute force and continuous success flags because I want to, the node brute force option, what we're doing is we're saying one username to one password. So map John Doe to test and rather map John Doe to password 123 and test user to test user 1. All right. And then we're going to continue on success because we want it to continue brute forcing even if a valid credential is found. All right. So we're going to crack map exec SMB connect to the whole network and see what happens. And this is a domain logon of 80.lab. And you'll see that test user 123 with the password test user 1 exclamation point has administrative access to 10.80.80.3. So the next course of action from here is to go ahead and make a lateral pivot. When 10N1 is 10.80.80.3. Now, just want to make a quick note that because this is a planned exercise, due to the time limit for the study group session, this whole thing that you're seeing here doesn't accurately reflect the proper enumeration techniques you'd take to plot your next hop. Yes, dumping hashes is one of the things you'd want to try, but you should also run your Nmap scans on the network. Make sure you do proper enumeration before you begin all these attacks. You want to make sure that before you start attacking, get all your eggs in a basket. Run your Nmap scans, take inventory of what ports are open on different hosts. You want to be able to say, okay, this is my domain controller. How do I know it's my domain controller? Well, since we know, I've already pointed out that 10.80.80.2 is the domain controller. I've already said that to you, so we know that. But how would you know by running your port scan which one is the domain controller? I'm going to take the dash A off just to speed it up. But if you can still, even without the dash A, if you ran your port scan on the entire network, you could pretty confidently say which one is the, let me run out of dash P as well. You could pretty confidently say which one is the domain controller by looking at the open ports. So let me see. Well, it's going to take a while. Let me just crunch this down to 2 through 10 and see if that speeds it up any. We're going to bump it up to 10,000. All right. While that's running, we'll come back. All right, and we'll point out again. This is a planned lesson. We can't go through the entire enumeration process. The main reason for me putting this note here is that don't forget to do your proper enumeration. You get dropped on the network. The first thing you should be doing is your port scans. Take inventory. What ports are open? What services are open? Open up responder like I showed you there. Like that's also a thing you can do initially on your internal. Open up responder. Start trying to catch any potential hashes through an LLMNR poisoning. Now, I'm going to take the short route here with our lateral pivot. What I could do is RDP into the box and then run Mimikatz to dump the hashes off the box. Instead of doing that, instead of running an RDP session, transferring Mimikatz, and dumping the hashes to Mimikatz, I'm just going to use secret dump to do that remotely. So recall before. Oh, there we go. Port scan's done. So looking at our list of hosts here, which one is the domain controller? 10.80.80.2 is very obviously the domain controller because of port 88. just Kerberos, port 464, LDAP. I mean, yeah, very clearly ADWS. So lots of ports that are open that clearly designate this. This is our domain controller. The rest of these have SMB open, which is pretty normal for Windows hosts. Remote desktop. Again, looking at your open ports. All right, this is our domain controller. This is the host we're going to want to hit to do our LDAP queries, or what other queries you'd want to run against domain controller. Enum for Linux. MSRPC, RPC clients, et cetera, et cetera. But taking inventory, knowing this is our domain controller, is a big first step. That's something you want to do right up front. Throw up responder, run your nmap scans, take inventory, do your proper enumeration. Okay. Again, I'm not going to RDP in the box. We're going to dump hashes remotely. Again, we cracked that password earlier for test user. So, or take a look at the command here. Let me enlarge this a little bit. So the syntax here is in packet, synchronous dump, username, :password @ target. We know from earlier, just before running that crack map exec scan, we know we have local admin on 10.80.80.3 with test user 123. So we should be able to open up an SMB shell with in packet, create a service to dump the hashes and get them remotely. Let's see what happens. So starting the remote registry, and boom, here we go. We got hashes off of the remote target. This is essentially the same information. Mine is a little Mimikatz. You could probably dump that LSA for whatever reason. I'm not having any luck in LSA over secrets dump. Probably didn't configure my lab with some kind of permission for this account. But if you could just as easily RDP into the box, run Mimikatz and dump LSA. But for now, we're going to stick with our lesson plan. We do have some local SLAM hashes, and looking through the list of accounts, we have the local admin, we have a default user 0, and we have this template account and local user account. Last time I used the template account as our example. This time I'm going to use local user. Looking at this, so you just try to determine what are the most interesting accounts. Admin, but that might be disabled on the box. These two look pretty interesting. So what we might want to do after dumping hashes off the box is copy these hashes and then try to crack them. But again, since we're following a lesson plan here, let's see what's next. I will come back to the SMB, the NTLM relay in just a minute. But what we're going to do, pardon me there. So we're going to point out here that local user. In my lab, I've created this local user on the hosts. Again, I'm privy to this information because it's my lab. In the real world, you're going to be dropped on a domain that you know nothing about. It's just going to be a bunch of trial and error. You're going to dump hashes off the host, and you're just going to have to try to crack passwords and, again, spray them around and see what sticks. I have the benefit of this being my home lab. I know who my local admins are. You wouldn't in an exam environment or in a penetration test. So, but for the sake of time, I'm just going to take my hash here for local user and go ahead and output that hash to a file. And again, try to crack it using this command. So let's take a look at what we're doing. We've got John the Ripper. This is a NT hash, not NTLM v2. This is an actual stored NT hash. This is the LM hash portion of the NTLM, the stored NTLM hash in the SAM database. This is there for legacy purposes. you can ignore this. This half here is what we're cracking. This is the NT hash. And let's see what we can do. So we're saying John, format NT. We're going to try to crack this guy. And we're going to use this password list again and see if we can crack it. And boom. Now we have local user with the password 123, password 123. So what do you think our next step is going to be? If you're thinking that now we're going to take this account and spray it around the network, you'd be right. But I do want to take a quick detour because, again, I'm trying to pack as much as we can into our lesson here. I do want to show you guys NTLM relay. So if you recall before how we ran responder to poison requests, grab hashes, store them, crack them, and pass them, we can simplify this process a little bit using NTLM relay. So if you're thinking chronologically, you get dropped on the domain, you run your Nmap scan, you find your live hosts, now you have a list of IP addresses that you're going to attack. So this is essentially where we're at that phase. I'm going to drop this list of IPs in targets.txt. I've run my Nmap scan. I have my list of IPs. Now we're going to, instead of doing LLMNR poisoning, where we run responder, gather hashes and crack them, what we're going to do is just relay those NTLM credentials, those net NTLM credentials, and see if we can get access to these targets here. So if we cat targets.txt, again, I know I'm kind of bobbling back and forth. Sorry if I'm confusing y'all at all. So just recall from before, what we were doing before is running responder, catching these hashes, putting them in a file and cracking them. Here's what we're going to do this time. We're going to edit the responder configuration. We're going to turn off the SMB server and the HTTP server because those servers are going to be run by Impact NTLM Relay X. However, we're still going to use responder to poison those responses. So what's happening in this scenario here is rather than catching the hashes, we're going to poison them, and then NTLM Relay is going to take the hashes and send them on to that list of targets. So the workflow is a little different. They're both valid ways. I just want to show you two ways of doing it where you can use LLMNR poisoning to catch the hashes, store them, and crack them, or you can kind of bundle it all up and just send the password, send the net NTLM hashes onto the targets, which would be, again, targets.txt. So let's go ahead and start responder. Now that we've disabled our SMB and HTTP server, let's go ahead and run it. And you'll notice here, Papo, that the HTTP server is off. The SMB server is off. So even if Kali poisons those responses like it is right here, and then the host tries to connect to Kali, the SMB server right now is not running, so we're not gonna see those hashes. All right. So let's go ahead and run the other half of the equation. We're going to do impacket NTLM relay X, and then point it at this targets file. So it's a two-part attack. Responder to poison and say, yes, connect to me. And now over here on the right side, we're running our SMB server and HTTP server. So when responder poisons the requests, now NTLM relays SMB server catches those and forwards them onto the target list, okay? Right here. And you'll already see we succeeded in dumping hashes on that same target as before. Right here, done dumping SAM hashes for host 10 to 8083. That would be this set of hashes right here, which if we compare it with what we did previously with secret stump, again, 10 to 8083 as I should show what we're authenticating as, but look, we're dumping hashes off the same target with the same user account. And let's just compare, just quick sanity check. Check that out right here. The set of hashes is completely identical. So you can choose which way you want to do it. Do you want an NTLM relay, or do you want to poison, crack them, and then basically do the relay yourself? So what we did here, instead of so let me go back and just reiterate. Turn those back on. So instead of catching the hashes, storing them, cracking them, and then using crackmap exec to pass it around, what we did is just bundled it all together with NTLM relay. So it's up to you. It's basically the same thing. You're just kind of taking a couple extra manual steps out of the way with this NTLM relay X over here. Basically just speeding it up a little bit to see, hey, can I just relay these credentials and possibly get an easy win? It's up to you. Either way to do it's fine. Okay. Sorry if I'm bouncing around a little bit. Hopefully you guys are tracking along with me. I'm not looking at the chat right now, so if you guys are saying bad things about me, that's, I won't know until later. All right. So we know that we've cracked local user, which means now we have the password, the clear text password for that local user. And again, if I try to run that John command, it's not going to work because I've already cracked it. So if you're ever in that situation where it's like, hey, I can't see my hash, you can just go here to just run show, and you'll see here the password is password123 exclamation point. So what we're going to do is pass that credential around the network and see what sticks. So recall from before, we took test user 1, 2, 3, or rather we took go back to lesson plan. We did crackmap exec and then passed a couple of usernames around the network. Okay, and then remember we dumped hashes off of 10.80.83 where we got local user, cracked that with John, and now we're ready to spray local user around the network and see what happens. Okay. So now is our next lateral pivot. Okay, we pivoted to 10.80.83. Now we're going to attempt another pivot, see what sticks. We're going to crackmap exec SMB around the network using local user with this local auth flag. This is not a domain login because this is our local admin. So we want to make sure when you're using crackmap exec or whatever tool you happen to be using, make sure you distinguish between local authentication and domain authentication. This is not a domain user. This is a local admin on that exists on each computer. All right. And let me close this tab here so we can see the output. Now, fancy that. We've got a local admin on 3, 4, and 6. All right. And the reason that works, and the reason that's a good thing to try, if you ever get a local admin hash, it's a really, really good idea to pass that around the network, because in a lot of businesses, what they're doing is they have a template computer, or rather a template Windows image that has a local admin account that typically has a password repeated on the image. So every time they deploy a new Windows host, you're looking at potentially having the same password because it's a template image. Now, if they're using a solution like LLAPS or some other local admin password rotation solution, then you're out of luck. But there are still a lot of businesses out there that don't take advantage of those kinds of solutions. So it's still a really good idea to pass local admin hashes around and see what sticks. And in our case, it's worked really well because we have local admin on a ton of computers, which would, essentially opens up a lot of opportunity for mining from, again, with Active Directory, your goal is to find credentials. Well, with this attack vector, now we have leverage on 2 more hosts. We could get on 2 more hosts and hunt for more credentials. And perhaps with any luck, the domain admin may be logged in, or somebody with privileged access may be logged in, and we can dump those hashes using our local admin. We can dump those hashes right from the LSA or SAM, and then again, proceed to pass those around and hopefully continue our mission of escalating our privileges. So we're going to pivot to 10.80.80.4. Since we already did 10.80.83, we dumped hashes. Now we're going to go hunting for more credentials on 10.80.80.4. So let's go ahead and get our RDP session open with local user. We have our command here, xfree RDP to the target 10.80.84 as local user with this password. And we're going to map a drive. So what this syntax here is, we're going to basically, that dot being this folder here, that's basically this notation right here. That would be, PWD. So we're saying map this folder as a drive across the network, and we're going to label it CaliSure. So let's just take a look and see what that does, okay? But always good to go over your commands so you know what you're doing. Don't just blindly copy and paste. All right, so we'll open up our remote desktop. Okay. Now, again, this is a planned example. So again, I know where the things are planted. If you were in an exam or a penetration test, you don't have that luxury of knowing where things are. So now you're on the box. Now what? Well, you figure out, okay, who am I? What's my privilege level? Can I dump hashes? Where else can I hunt for credentials? Well, you'll see right here, this is a pretty interesting looking thing on the desktop here for this user. We have a PowerShell script. Let's go ahead and take a look at that and see what's in that script potentially. Okay, so we have this PowerShell script that is already looking really interesting. We have this SMB cred file. It is stored in a CLI XML, which is a PowerShell XML format for storing PowerShell objects. So the script first imports that PowerShell object from this cached file, and then we see that this script tries to open Jones PC files share using this username and password. So if we mimic what the script does, with any luck, we may be able to reveal the clear text password. So let's try that. Let's go ahead and copy and paste these commands here into a PowerShell window and just see what happens. I think I cut that. So okay, let's see. We'll see if we get any errors when trying to import that file. Oh, interesting. it looks like the command succeeded, no errors. So let's just dump out what's in this file or rather in this variable. Is there anything in there? And there is. We have a username and a password stored as a PowerShell secure string. Let's go ahead and, again, so my cursor is a little hard to see. We'll just copy this text block here, and we'll run this again in PowerShell. Try this again. Okay, let's go ahead and look at this hash table here and see what's going on. If we dump out the hash table from the variable, interesting. We have a dictionary, a hash table, showing a username and a clear text password of Madison. So if you're thinking at this point, well, that's another credential to spread around the network, again, you'd be right. Let's go ahead and see what we can do with Joan Hester and the password Madison. And again, this is a domain logon because you can see by looking at the username, this is a domain user, not a local user. So now when we're going back to CrackMap exec, we want to make sure that we specify that domain logon. Okay. Oh, interesting. Joan is an admin on 10.80.86, but nothing else, which should be an indication to you, well, that's our next pivot. So let's go back to our lesson plan. I should have an RDP command in there. So let me minimize this because it's giving me trouble. So again, same command, essentially different target, different user, password, but still mapping a drive through the RDP session. So we'll go ahead and close this since we've got what we came for. And we'll go ahead and open up another RDP window. And again, we're on a desktop here, and the mission is the same. You need to hunt around for where credentials might be stored. And if you're looking at this LDAP administrator application on the desktop and thinking that looks very interesting, you'd be right. That is definitely something I'd be looking at for perhaps a stored credential. Okay, so now we're on the Win10N3 box. We're going to test an LDAP passback attack. This can be really useful on things such as printers or other network devices, even this computer here that we're on. Let's say you get access to a printer that's configured with an LDAP credential, because they do that, because if you're in a pen test, printers often have LDAP credentials because when a user goes to the printer and says, well, I need to scan this document to myself and I want to send it to my email. How do they start? They're not going to, it's really inconvenient for the user every time that they want to go scan a document to themselves. It's super inconvenient for them to have to type in their email every time they want to send a document. Instead, the IT team is probably going to configure the printer with an LDAP credential so that the user can just click the address book button and then search their name and very simply, very easily send themselves a scanned document using their email that they pulled from the LDAP lookup. It's the same thing here. Joan has decided that she'd like to make sure that LDAP works. And let's see if there's perhaps any interesting credentials stored in this program. Let me look at my lesson plan. It's been a bit since I touched the app. So we're going to go to Tools, Credentials Manager, and we're going to duplicate the existing credential because on a pen test, it'd be nice if you didn't destroy the client's apps. Try to leave them in. I mean, if if you're in an approved environment where it's okay to wreck things, and that's different if it's like a staging environment or something they can easily rebuild or a purpose built thing for the pen test. It's different. But if you're in a production environment, if we have this opportunity to duplicate the credentials so we don't destroy what exists, that's a better idea. So we'll go ahead, go to Tools, go to Credentials Manager, and look at that. We have Domain Administrator credential stored in this application. So we're going to duplicate it. And the first thing we need to do here is to find, okay, if we're going to duplicate the credential, what server are we going to connect to perform our LDAP lookups? Well, instead of putting DC1 here, or instead of putting 10.80.80.2, which is the domain controller, this is what Joan would have done if she was duplicating the credential, because she wants to run LDAP lookups against the domain controller, which is what a normal user would do. But we're not normal users. We're here to pwn the domain. So we're going to put in Callie's IP address right here. And we're going to go ahead and run a listener on port 389, which is the default LDAP port for unencrypted LDAP. So go ahead and start our listener, and let's go ahead and run. Let me double check my lesson plan, make sure I didn't write my notes to prevent myself from looking silly. Looks like we should be good, and we'll go ahead and click OK, and then we'll go back to our Callie box and see what happened. Looks like it didn't work for whatever reason. Try this one more time. Let me double check the address 80.5. Okay. Try duplicating it one more time. For whatever reason, I'm not getting that callback to Callie. Not sure what the issue is here. Let me make sure. Let me open up a PowerShell window. It was working in my testing, so let me make sure I can ping Callie. Yeah, can get there. All right. We'll just remove this. And we'll just have to pretend that we are passing back. It's a little bit frustrating, but we'll see if this works. I'm not sure if it's something happened with the application. Maybe it rebooted and something was destroyed there. But what we'll just before I spoil it, before I run this bars, let me just go ahead and sign in as domain admin. Sorry. 10.80.80.2. I want to try to duplicate it one more time after saving the password here, so we can really make it look like a proper passback attack. And if it doesn't work, we'll just figure something else out. You know what I probably might need to do is after duplicating it, well, let me see here. That's working fine. Let me try destroying this here. Delete. Let me try adding pwned back, and we'll do 10.80.80.5 here. There we go. All right. Okay, we didn't get the credential yet. Sorry, guys. I am really not sure why it's not wanting to work with me here. Try it one more time. If it doesn't work, we'll just have to pretend it worked. All right. Try it one more time. But the benefit to this is that you're witnessing the trial and error that you would see on an actual pen test, because things typically don't go as planned. So yeah, I'm not seeing the credential there, but it's one thing we can try as a workaround is let me see if responders gonna catch it. Maybe we can modify this one. Oh, there we go. Okay. Well, those are our other hashes from the user activity. Here, we'll try. Yeah, it's frustrating, guys. I'm sorry, but well, that would have been a passback attack if I could actually get it working. Hate it when it works in my lab, but it was working in my lab before today's exercise, but it's not working now. So try this one more time up here. Let's see here. Yeah, I don't know why it's not working. I could try rebooting the host, but I don't want to, I want to tie up everybody's session here. So, but essentially, what's supposed to happen is you duplicate this credential here, point it so that it connects to Kali, and then we should be catching the password here. But of course, it's not going to work. I'll try it one more try, and if it doesn't work, then we'll just have to go on. Let me see here. Let's see if there's oh, there we go. Okay. No, so still, Yeah, I'm not seeing should be getting the pass. So what you should be seeing is here that we should be seeing domain admin and password here. So you can see it is making a connection, but not with the credential. So, but you get the gist of it. That would be a passback attack for whatever reason.
Jacob asks if the password would just be in clear text.
Yes, they should be here. I'm not absolutely sure why. We're not getting the passback attack. Really unfortunate because, again, as I mentioned, it's working just fine in my lab. But let me try. Yep. So there we go. No, so we're still getting it. I thought I saw domain admin username in there. But yeah, I'm not sure why that credential's not coming through in clear text. It should be. So, well, that was that would have been the path domain admin right there. Let me try with responder one more time. And let's see if we got domain admin there. Yeah. I'm sorry, guys. It's frustrating. There we go. Oh, there we go. Nice. There it is. Okay, sweet. Responder saved the day. All right. Finally got it to work. Let me stop responder so I can point it out right there. There's LDAP. There's the LDAP clear text client right there. 108086 with domain administrator and the clear text password. Thank you, responder. For saving my skin here on this presentation. But yeah, I'm trying to blow up there we go. Blow up the text. There you go. And the reason that works, again, is if you look at the responder configuration, you'll see that there is an LDAP server here that you can run. All right. So nice way to swoop in there and finish that off. So we got our domain admin credential, and now we can do our crack map exec. All right, and we can do domain.admin with a password 123 exclamation point, which is, we see right here. And oops, got a typo in there. And there you go. We've pwned the domain controller with that credential. And that takes us just about 15 minutes shy of our cutoff point. So I'm going to wrap it up there in terms of our presentation. And let me know if you guys have any questions. Sorry for the flop there at the end. It definitely did not did not go as planned.
No, that was actually good to see you get to work through it, because that's how every lab goes for me.
Yeah, well, yeah, that's why it's good to always have a plan B. I mean, know your tools.
Mm-hmm. Keep pounding the keyboard, he says.
Yeah. Yep. But yeah. Any questions from anybody?
We'll give everyone a couple minutes to just ask away before we
Thank you,
wrap.
Syntapalon, for that. I appreciate that. Yeah. It was an all right, definitely an all right exploitation chain. I mean, it's for what we can do in an hour and a half, but I think it's good PJPT level stuff. Good. So
Well, thank you for coming,
I'm
Susie.
glad you enjoyed it. Yeah, thanks, Susie. I appreciate the compliment. Appreciate you being here.
Kumo has a question.
Yeah, so WPAD is just a proxy configuration file that the host. Oh, so the question, yeah, forget this from last time. So I've seen LLMNR used with WPAD before as a DNS fallback. Can you talk about that? So WPAD is just so you can send a poisoned WPAD configuration file that just says that the authentication proxy is Kali's IP, and that will send those net NTLM or authentication requests to Kali's IP instead of just using LLMNR. So yeah, if you want to use WPAD poisoning, you can definitely do that. I think that's what's used in the IPv6 man in the middle 6 attack. There's a poisoned WPAD file that's issued to DHCP clients.
Looks like earlier Wildfire was wondering if you can do maybe you reuse responder with proxy chains.
You can use responder with proxy chains, but only to catch specific requests. So if you wanted to do the port forwards, I don't have a diagram in front of me right now, but if you let me go back to my network. Let me go back to that. I'm going to pull back up the Kali screen share, and I'll do last week's lesson plan just to kind of demonstrate it. And that if you had your pivot host right here, and you port forwarded SMB back over here, and then you targeted your NTLM requests, or basically you so if you basically did whack / 108089 here, and then you port forwarded that back to Kali, that would enable you to catch that single one-off hash. Or basically, if a dumb user accidentally typed this here, but you'd have to have either the poison set up on this box, or if you already had like a shell on one of these boxes here, you would send the NTL, you would send the SMB or other protocols at this IP and forward those ports back to Kali, where responders listening on ETH0 or whatever interface you happen to be running on. You can catch, so you can catch hashes in that regard. You're not going to be able to poison. You can't poison through that pivot. All you can do is just run responder over here so that you can catch the forwarded request through the proxy. But short of that, and some, it's really not worth it at that point. At that point, you might as well just be over here and put some tools on there like Inve, or if there's Python on this box, try to, if it has internet access, try to install responder on there, or you might as well just drop tools on this box. It's really not worth the headache of trying to run the port forwards. It'd just be better to drop the tool in this box if you can.
Sozi asks if we can do a session on enumeration. Yes, absolutely. I can plan that for an upcoming. I don't know if I'm going to have. I don't know if I'm going to be able to do a study group this week. I have a job interview on Tuesday I'm prepping for, and then I'm taking the Dark Wolf hiring CTF. So I probably will not have time for a study group this week, but I can try and do the next one on enumeration.
Yeah. Kumo Monomu is asking, you can register yourself as a DNS server over DHCP6. That is that man in the middle 6 attack I was talking about, where yes, you're registering yourself as the IPv6 router for the local area network, and so once you make that broadcast and you're saying, hey everybody, you send an IPv6 broadcast and you say, hey everybody, I'm your IPv6 router and DHCP server. So if you guys need an IP address, hit me up. And then then those IPv6 clients are sending DHCP requests to your IP, and you're poisoning the WPAD file and other things like that. So yes, that's definitely networking basics.
Brandon, thank you. L30, thank you. The interview is for senior cybersecurity engineer at SAIC on Tuesday.
Get it, dude. Good luck with it.
Yeah, I'm hoping. I'm going to be living in web app for the next 4 or 5 days.
You got it, man. You're gonna crack it.
Thank you. Yeah, SAIC does government contracts.
Looking up through the chat to make sure I didn't miss any questions, but yeah, even when Blue Penguin was saying even when WinRM can pass the hash, you certainly can.
But not outside of a local admin, right? I think.
Yeah, or unless you're in the remote management group, unless the user is part of the remote management group, then they could. But yeah, it just depends on your level of access. You can, but there is an option with that tool to pass an NT hash.
Thank you, Sozi. Good day or good night to you too, local hostel.
Yeah, have a good one. Thanks for coming out. Appreciate it.
There's also a nuance between NTLM and net NTLM, right? Asks Kumo.
Yes, very, very big. Yes. Yes. So net NTLM is just basically the protocol through which the client and server exchange. It's a challenge and response protocol by which they exchange NTLM credentials. So yeah. So
any other questions, my friends?
Yeah.
All right then. Thank you all for coming. I guess we'll wrap up.
Yeah, thanks very much for joining.
And I know that was a lot of information to take in, so it will be on YouTube. I'll try to edit it real quick and get it going on, and it should be there tonight or tomorrow.
Really, you doing that, Sean? Thank you.
Of course.
Thanks,
it's B-Dubs. I didn't know you was here. You must have snuck in.
Oh yeah. Thank you for reminding me of the L30. I'll link my main blog and my wiki are coming right up in the chat. Sorry. Thank you for reminding me to do that.
And buy that man a coffee.
No pressure.
I probably owe him 365 coffees. I don't know if Ben is a beer guy. I don't know.
I do. Yeah, I like a good beer. Yeah.
All right, favorite beer real quick before we go.
Oh, my favorite beer? Oh, I thought you were saying my favorite beer. Okay, yeah. Well, most of the local breweries here like this. There's this one out in Purcellville that called Adroit Theory, and they have it's AD. Check it out. They have really cool artwork. If you're into death metal, you'll like their artwork on their cans.
I may be. All right, we'll wrap it up then.
All right, cool. Well, thanks, guys.
Have a good night, all.
And gals.